Hello everyone, I hope all of you are having a great time and welcome to day second of February Leetcode challenge. The question that we have in today is find all anagrams in a string. Here in this question we are given two strings S and P and we need to identify the starting indices of P's anagrams in S. So here they have provided us with an example. I'll be walking through this example and the approach to go about it by the presentation. Also, I'll be telling you two ways to solve this question. So stay tuned till the end of the video. Find all anagrams in a string. Leetcode 438. It's a medium level question on Leetcode and I totally feel the same. So let's get started. Let's start by defining what do you mean by an anagram. So let's consider the case where we have a string ABC, and if you want me to tell what will be its possible anagrams, one would be CBA, CAB, BCA, BAC. So the order really doesn't matter in anagrams, the characters does matter. So if there is a string S, you can permute all the characters in any order and that would become its anagram. Now let's start by discussing the naive approach and let's use the same example that was specified in the question. We have the input string S as CBA, EBA, BACD and string P as ABC. So what do you do in the first case? You go and generate a substring of length 3 and that would be equal to CAB starting from the 0th index. You compare all the characters that are present over here with that are present over here. If they match, then you find one probable answer and you add this particular entry into your answer set. So let's check whether CAB matches all the characters of ABC. It does. So we add 0 in our answer set. So 0 gets added. So let's proceed ahead. We generate the next substring that would be equal to BAE. And let's compare it with ABC. It doesn't match, so we skip it. Next we have is AEB. It doesn't match. Let's skip. Next we have is EBA. It doesn't match. Let's proceed ahead. Next we have BAB. It doesn't match. Next we have ABA. It doesn't match. Let's proceed ahead. Next we have BAC. So BAC is an interesting case because it matches with all the characters of P, ABC, and the index that we are currently at is at 6, so we add 6 to our answer set. Let's proceed ahead. Next string that we see is ACD. It doesn't match with ABC, so we are done with the iteration of the input string, and the two indexes that we found out while iterating through the complete string turns out to be 0 and 6, where we found an anagram for P, which is nothing but ABC. The time complexity for this approach is equal to order of length of P. So let's write len P because you're checking whether all characters are present with the substring that you have generated. So len P into the number of substrings that you could generate, that would be equal to length of S in the worst case. So the total complexity turns out to be equal to order of length of P into length of S, which is quite high. Can we optimize this? The answer is yes. How can we optimize this? We can use a two-pointer approach to solve this question. And how two-pointer approach will help us reduce the problem, you'll get to know in some time. So let's get started. In the first step, what do? I create the frequency map for all the characters that are present in P. And let's get started. The first character that we see is A, so we update the frequency from 0 to 1. The next character that we see is B, so we update the frequency from 0 to 1. The next character that we see is C, so we update its frequency from 0 to 1. Also, I create a new variable named total unmatched characters. So let's write it total unmatched. Remember, unmatched is important because we'll make the comparison with the input string S. And by default, what it would be equal to the length of P. So let's get started. We have it initialized to 3 and we have appropriately built in the frequency map. Now we will use the two-pointer approach and listen to me very carefully. So let's create two pointers. One is S, that means the starting index, and other one is ending index, which is pointed by E. Let's start the iteration. So the current character that we see is C, and let's check what is the frequency of C in our frequency map. It is greater than 0. That means this character was present as part of P. That also signifies that we found a matching character. So what do? We simply reduce the frequency from 1 to 0. So this gets reduced to 0. Along with this, we also reduce the unmatched count. It gets reduced from 3 to 2 since we found a matching character. Also, along with this, we'll increment the E pointer. So E now points to B. And let's again check the frequency of B in our frequency map. Is it greater than 0? The answer is yes, it's greater than 0. Again, that simply signifies that we found a matching character. We reduce the frequency to 0 because we consumed it, and we also decrease the unmatched count by 1. It gets updated to 1. Let's proceed ahead. Next we see is another A. Let's check the frequency in the frequency map. Is it greater than 0? The answer is yes. So what do we do in such case? We reduce the frequency by 1 and it gets updated to 0. Along with this, we also update the unmatched character count by 1, so it gets reduced to 0. Now comes the interesting case. Why? Because as soon as we did this, we see that the unmatched pending characters has been reduced to 0. That simply signifies we found one possibility for an anagram. We add the current starting index to our answer list. So 0 gets added as the answer list. And let's move the E pointer by 1 position. E points to this particular index. Now we will also move S along with this because the window size should always be equal to the length of P that we have. What is the window size? The window size happens to be in this case is 4. We have to also increment S. So we will go step by step. We will simultaneously increment E. Along with this, we'll also increment S. So let's do the same thing that we have been doing so far. We see a character E. We check its frequency in the frequency map. Its frequency is 0. So what do? We again reduce the frequency by 1. So frequency gets updated to -1. Also, since the frequency was 0 previously, that means it was not part of the matching character list. So we don't do any operation over here. While moving the S pointer, we'll have to undo all the steps that we did while incrementing the E pointer. And what are those steps? Let's look at it. The character at S happens to be C. So we go and check the frequency of C in our frequency map. What is the frequency of C? The frequency of C is 0. That simply signifies that this character was part of our answer set. Otherwise, it would have been set in negative as E is. What do we do in such case? We simply increment the frequency by 1. It gets incremented to 1. Along with this, we also update the unmatched character count from 0 to 1 because we are removing one successful case from our substring. As a result of which, we have successfully created the unmatched character count for the string BAE, and it happens to be greater than 0. As a result of which, this index will not act as the answer index. For the substring BAE, the unmatched character count variable signifies 1, which is in sync with our expectation. Why? Because the input string P happens to be ABC and C character is missing from ABA. As a result of which, unmatched character count appropriately signifies this value. As a result, one index, the starting index of BAE doesn't get added to our answer, and we right now only have 0 at it. Now what do you guys need to do? We will move one by one. So E points to this particular location. Along with this, we move S to this particular location. We consider this particular substring. We update the unmatched counter appropriately and we check. In case it happens to be 0, then we add the current starting index to the answer. Otherwise, we'll skip it. And it will happen only at the 6th index in the further substrings, which is this particular case. So it's an exercise for you guys to completely dry run it up till the end. And for those who still have confusion, don't worry, everything will be clear in the coding section, and I'll exactly follow the same steps that I have talked here. Here I've created my list that will store all the indexes where I found the anagram strings. As told in the presentation, I created a variable unmatching character count and initialized it to the length of the T string. then I go ahead and check whether my T string happens to be greater than S string. If that case, it's not even possible to have a matching case ever, as a result of which I simply return my answer variable and it would be equal to new array list. If it's not the case, then I go ahead and create the frequency map and I iterate through the input T string. I update my frequency count appropriately for each character present in T. Moving ahead, I create two variables, start and end. I iterate over the S string, and this time I'm only iterating till the length of T. And here we'll simply increment the end pointer. So we go one step by step, and in case I find out whether my current character at the end index frequency happens to be greater than 0, that means I found a matching case and I simply reduce the unmatching character count by 1. Also, with each progression, I reduce the frequency at that particular index by 1. Once I'm done with this, I check whether the unmatching character count has been set to 0. If that is the case, I simply add the starting pointer, which happens to be 0, into my answer set. Otherwise, I start a for loop till the time I haven't reached n.s.length, and here with each iteration I will increment the s pointer as well as I'll increment the end pointer. So I extract the starting index, the current character at the starting index, and I extract its index to search in the frequency map. If my frequency map at the start index happens to be greater than or equal to 0, that means that character was present in T. As a result of which, I increment my unmatching character count by 1. I also increment the frequency count at the start index by 1. Along with this, I increment the start counter as well. Similarly, I follow the same steps as I have talked above. I extract the end index, I check its frequency in the frequency map. If it happens to be greater than 0, that means I have to reduce the unmatching character count by 1. I do that and I proceed ahead by reducing the frequency at the end index. Once I'm done with both the steps, incrementing the start pointer as well as the end pointer, I simply check whether my unmatching character count happens to be 0. In case it is 0, I simply add the starting pointer into my answer set. Once I'm done with this loop, I have appropriately set all the positions of my anagram starting indexes in my answer set, and I simply return it. So let's try this up. Accepted, 94% faster. The time complexity of this approach is order of n, because you're iterating through the input string s only once. The space complexity of this approach will also be of order of n. Consider the case we have a string s as AAAA and t as string a. Then we have to store all the indexes where we are seeing a's. As a result of it, in the worst case, the space complexity for storing the answer result happens to be order of length of s. This brings me to the end of today's session. I hope you enjoyed it. If you did, please don't forget to like, share and subscribe to the channel. Thanks for viewing it. Have a great day ahead and stay tuned for more updates from Coding Decoded. I'll see you tomorrow with another fresh question, but till then, goodbye.